just give the floor to Iain. Thank you very much.
It's a pleasure to be here. Thanks for inviting me. And I have to say that I sat through the panel session earlier on today on decarbonisation. Yeah, some of you would have been there, some of you not. But actually, just about everything that I'm going to say came up in that session. So it has been really interesting and hugely impressive, actually, in terms of the discussions that are going on in this building about responsibility and role of geoscientists in terms of the public good. And that's really the key thing that I want to talk about. So yeah, so if I said to you, has geology got the solutions to many of the world's most acute problems? I'm not even going to do the test, because virtually everyone in this room would say yes. Now, I could then, if I wanted to be cruel, go through the Sustainable Development Goals and ask us where we fit. But the point is that I think everyone agrees that actually geoscience has a tremendous role to play in addressing the infrastructure of the smart cities of the future, where we're going to get resources for this 9 billion people that's coming, where we're going to get energy, and of course that's old energy, so what about the new energy, the clean energy? Water, clean water for the, there's 9 billion people, where we're going to get from under the spectre of climate change and the environmental effects that we might have, or we often have, as a result of many of these activities. These are pretty big and crucial and complex issues. And at the heart of them is the geoscientist. And yet the geoscientist often is one lamenting that they're cut out of the picture, that they're disconnected somehow from this wise environmental decision making that's going on, and getting frustrated by the fact that they don't seem to be in there amongst it. And that's one of the things that I'm really interested in. So the first thing that I want to start with is what has been referred to as the risk paradox. This is a photograph I took from Khao Lak after the 2004 Indian Ocean tsunami. And the risk paradox, the essence of the risk paradox is saying that we can raise awareness, we can tell people information, but that doesn't necessarily motivate them to behavioral change. So that our knowledge can contribute to the understanding of, in this case, tsunamis, but actually what happens next is kind of disconnected from that. And we see it again and again and again. And I never appreciated this. This was 2004. I went out there in March 2005. And 2005 was a big year for me because I also went that year to Merapi. And I climbed up the top of Mount Merapi. And at the top, Rudy here, the volcanologist, explained to me about how they were monitoring the volcano. And he said, we've got these gas and temperature gauges, and there's all this stuff. And we can give many hours to often several days warning that there's going to be a volcanic eruption. And that means that there could be an evacuation put in place. So we filmed it, we wrapped it up, and we started walking down the volcano. And as an aside, Rudy said, of course, the odd thing is none of the villages at the top of the volcano evacuate. And I was like, what does that mean? And he said, well, it's supposed to be to do with the cultural connections. I don't know. They just don't evacuate. So I got a PhD student, Kate, to start looking at it with human geography, and we started looking at this. And the reason why we were perplexed is it plainly didn't work, this indigenous knowledge. This is Mar Barajan, who's a spiritual gatekeeper of Merapi, and this is Turgo, which is a village in the upper flanks, which in 1996, when there was a volcanic crisis on, and the mandatory evacuation was in place, didn't evacuate. In fact, they held a wedding on the Saturday night, and a pyroclastic flow came through the community hall and killed 40 people. So there's clearly this connection with the volcano, with this spirituality, was in my view, undermining the whole volcano science. Volcano science is compared to earthquake prediction, is really, really good, and yet it was getting undermined by this stuff. And so Kate looked at this, and actually what came up with at the end of the PhD was something along the lines of, she said, well, yeah, there is this stuff. The older ones go with this, they keep the humour Mar Barajan. Actually, the real reason people don't evacuate is that they cut down vegetation, grass, they feed it to their one cow, and they sell the milk. So that when you say evacuate, they look at their one cow and they think, if anything happens to that cow, my family is more likely to come to harm from that cow being harmed than any pyroclastic flow coming through. So they do what I would regard as a rational risk decision, and they say, I'm going to stay put. Because someone might nick my land as well. There's a whole bunch of other reasons. The point is, it's rational decision making. It's not the same as what the scientist is thinking, because we look through that lens of science. We don't look through those other lenses. And it's not just going to developing countries. You go to La Conchita, this is between, it's actually in the news at the moment, a lot of firestorms around this area. It's between Los Angeles and Santa Barbara. It's on the Pacific, runs right along here, just off the shore. And then you can see there's a mudslide, or a landslide, which has then been generated in a mudslide, January the 10th, 2005. And all these houses, 30 houses have been kind of destroyed, and 10 people died in this mudslide event. And I went there with Jeannie. Jeannie lives in this house. This is Jeannie's house. And the mudslide actually went up to the top, halfway through up to our first floor. And they used that window, emergency services, to get the body of Charlie, our best friend, out across the road. And I was there a few months after this, so it was very raw. Charlie's birthday had just been the day before, and Jeannie's had been 2-3 days before. And we walked up this road, and this house here was for sale. And I remember saying to Jeannie, well, no one's going to buy that house, because the USGS have done loads of technical studies, and they all say the same thing. The next time you dump a load of water on that slope, it's going to remobilize, and that mudslide's going to move into this next set of houses. And she said, that house has been sold, and the value at a higher price than it was before the landslide. And suddenly at that moment, probably more than any other, I realized I really didn't understand hazards. I said, that's crazy. And so the point was that what I had misunderstood was not just hazard and risk, but I was looking at the physical processes, and what I didn't understand was the human processes that was going on alongside, the juggling act that every one of us makes and these communities make. So what's been really critical for me is television, because television is fixated by this lot. They're called the public. They don't really exist, because the publics are a whole set of multiple publics and all the rest of it, as we'll come to in a second. But television is fixated, but it's not necessarily in focus groups and all the rest of it, but certainly thinking about who they are and what they're interested in. So I'll typically get a producer or a commissioner saying to me, I know what a BBC Two viewer likes or understands, and they don't understand this, or you should change this. So I want to talk about the public a little bit. And I'll take my cue, you can take a cue from lots of places, but I'm going to take my cue from a CSIRO study on community attitudes. It came out in 2014, it's a PDF you can download. And this kind of tries to summarize where the human and behavioral science literature has got to about how people behave and how they relate to science. And the first thing really is on attitudes. And according to the Australian study, there are different ways of segmenting the public. So we segment the public in all sorts of different ways for communication. This Australian study is very Australian. It's got these groups, fanboys and girls. Let me tell you, you are the fanboys and girls. You might not know it. About a quarter of people are close to science, can have conversations about science, comfortable with science, watch science documentaries, read science articles, can have a conversation about it. Then there's the Mr. and Mrs. Average. They're a little bit older, a little bit further away from science, still, relatively comfortable with it. Might watch the odd Blue Planet or something like that, but probably wouldn't read New Scientist. Then there's a group that's actually the most voracious for science, the wish I could understand. They tend to be a bit older. They're the ones that go to museums and science centres the most, but when they're confronted with science, they don't understand it. It's not conveyed to them in the way that they can understand. And then there's some groups that are less well meaning towards science. One of them, which is quite big, is it's kind of saying it's nothing to do with science. It's just I'm interested in other stuff. Interested in politics, music, whatever. I don't really have time for science in my life. And then there's the ones who really don't like science. They hate, their chemistry teacher was horrible to them or something like that. And they've just, ever since then, their kids have science homework and their hairs in the back of the neck go up and they go, I don't understand this. They would not watch a science documentary. They would not read a science article. And then there's a group which is very small in this survey that says, I don't care about science because I know how the world works. And it's some other paradigm, it's religion or some other lens, it's pseudoscience, it's crystals, it's Gaia, it's something. So the question, so one of the things if you're in communication is you can't reach everyone. So you think, well, who do you try to reach? And I usually go through a long process of getting us to discuss it. But I'm going to cut to the chase here because I think the key people, these ones are easy. They're already interested in science. So the question then is, well, do I go to the left and have this group? Or do I kind of go to the right and try and get this group? So the advantage of going in this area is it's bigger. And the point is that these are the people who are called the disengaged. They're the ones that are not interested in science, apparently, because of other reasons. But if I can connect whatever I'm talking about to their issues of concern, then I can pull them in. So that's a case of framing the science in ways that are interesting to them. And for this group, it's a different problem. It's, can I convey the science in a way that wasn't like they had it at school? So that someone would say, God, if I'd had that at school, I'd have been really interested in taking science. And both of those are relatively easy to do if you can think about it. I'm not really interested in reaching this lot. They're not interested in me. Well, they'll write to me in red crayon telling me, that gravity's wrong anyway. But probably more interesting is I'm not that interested in this group, which is kind of you guys. So why, I say that quite apologetically, so why am I not, what I'm saying is I'm not interested in designing my programs for the fanboys and girls. Why? Because, yeah, you guys are already interested. You're already kind of going to watch. If I frame this even halfway right, a whole bunch of this group will watch because they're interested in it. So the framing of it, the design, is for your central groups and for these other groups. And normally I do this if I'm doing this to an audience, well, I mean, sometimes this is the reason, who thinks the music's too loud in the programs? That's why the music's too loud. Because people in this group say, well, I don't need loud music to get me going. No, you don't. But these groups do, because they're bored. Or me jumping into a bath of oil, or doing something really stupid as a presenter. I don't need all that. Someone said, well, why can't the rocks just do it? Well, the rocks will work for this group, but not for others. So you have to have someone on the remote control going, hold on a minute, that guy's just jumping into a volcano. What the hell's that all about? So the point is about how we frame our messages. And in terms of television, it's really trying to get into that mainstream lot, which is not the group that goes to university and learns geoscience. They're a different group. So I think there is this fundamental difference that has to be made between education, which is in universities, and entertainment, which is what this is, essentially. Now, it might have education alongside it, but first and foremost, if it doesn't entertain, then it's not working. So the other thing is that the Australian study does is it looks at values that underpin this. So I thought I'd do a test with you here. I went down to Fernhurst, which is just south of Guildford, and there was a question. We did it for Newsnight. We were talking about fracking. So I'd like to go through and see whether you think these people are for or against fracking. So you can just do you can just do that if you're for or against. Do that. So our couple here in the close, what do you think? Who thinks they're for fracking? Against fracking? All right, they're for fracking. Let's try. This couple here, he's washing the car. She comes out to wonder out what we're doing with the husband or whatever. Who thinks they're for fracking? Against fracking? They're for fracking. This chap here, let's make it a little bit easier. He lives in a very posh house, 500 feet from the fracking site. Who thinks he's for fracking? Against fracking? He's against fracking. Lovely lady here with a little gorgeous toddler. Who thinks she's for fracking? Against fracking? She's for fracking. Old timer, lived all of his life in this village. He's seen it rise. He's outside the pub. Who thinks he's for fracking? Against fracking? He's for fracking. So these ones here, they say, I think it's going to bring jobs. That's what I hear. You know, it might bring jobs into here. This guy, he says, I don't want this being a rich stockbroker village where everyone works in the city and things like that. I want this to be a real village. This chap here, you can't see he's in his slippers. He's come out, he lives on the green. He's got a UKIP poster in his window. Who thinks he's for fracking? Against fracking? He's against fracking. Doesn't like it. This lovely lady here owns the B&B and the local pub. Who thinks she's for fracking? Against fracking? She's against fracking. She says, I'll make, as Clive said, more business. There'll be more money coming in. But this is ripping my community apart. It's ripping my village apart, and I hate it. It's horrible. I want it to stop. The interesting one, I think, is this lady here, who said to me, yeah, I'm kind of for it. I think it'll bring jobs. And then she said, of course, I don't know anything about it. So I reckon it would take her a minute talking to this guy in a cafe or a pub to be completely against fracking. In other words, these things are on a knife edge. And the reason why it's so difficult for us to work it out is because really what we're trying to gauge is not their attitudes and their knowledge of science, but their values and their belief systems that underpin this. So the Australian studies, it talks about these value-laden questions that it asks. And so some of these questions are around this. So the benefits of science and technologies are greater than the harm, is one question it might ask. We depend too much on science, not enough on faith, to bring out these alternative viewpoints. Science tends to benefit the rich more than the poor, etc. So what that does is by people saying where they sit, if you like, on the spectrum, you can discriminate different value-based groups. And they discriminate 4 groups on the basis of this. And they're increasing order of science, interest in science, support in science towards the right. So you've kind of met the science fans, the group A. The science fans are ones that say science and technology is good. It's good for the world. It's got the solutions we need for the world. The B group, the cautiously keen, says science is okay, it's good, and generally it's positive, but there are some aspects about science and technology that I don't like. The risk averse is kind of a nostalgic group. It's a conservative, the small c, that says, why can't the world just be the way it used to be? Science and technology is turbulent, it's mixing it all up. Just set it back the way it used to be. And then group D is the concerned and disengaged. We've met them, they're either concerned that science is actually bad, or that they're just disengaged because they're interested in something else. What I'm going to show you then is how these plot up against a number of those value-laden questions. And I think there's something interesting about green, because I'm kind of assuming everyone's in this room's green, more or less. So there's something there about green, which just shout out if you see what you think it is.
Outlier.
Outlier. Oh, perfect. You guys are so good. It's the outlier. It's not just on the extreme, it's not just on the edge, it's actually disconnected, it's decoupled. So there's overlap between, say, B and C, C and D, even between B and D. There are shared values in those different areas where people can connect. But we are disconnected, we are decoupled. So this is the paradox that the A group is the group with the knowledge and the competence in science and technology, and this belief that science and technology is good for the world, and yet we are the outlier in that set of other social groups. So as long as we're talking to ourselves, we're fine. But if we're trying to talk to normal people, we've got ourselves a little bit of a problem. So the conclusions of the Australian study are this. when information is complex, people make decisions based on their values and their beliefs. So in other words, they could, in the case of fracking, they could go off and read, there's tons of stuff out there, loads of stuff. They could go and look at all that, or they can do what actually we all do about these things, complex stuff, is we go for a gut instinct internal shortcut, which is our values and beliefs. We then look to affirm those values and beliefs. So if we're searching for information on the internet or whatever it is, what we're really looking for is our values to be strengthened and reinforced. We really do not like to question our own values or others to question our values. So that means that as we move through all this material, any material that is counter to those attitudes, that says we're wrong, is ignored, is tuned out, because that's not what we're looking to do. We're looking to reaffirm them. And then there's this one that people most trust those whose values mirror their own, which is kind of the point of that previous slide. So if we are decoupled from the values of others, then we can be tuned out because people say, well, I don't share values with you, so therefore all the things you're telling me is irrelevant. When the Australian study said, if you're not going to take your science from scientists, who would you trust? They said friends, family, and radio hosts, radio commentators. Chris Evans, whatever it is. And that's the reason, because that's the people they listen to all the time about whether they should, I don't know, buy a new car, what kind of car, or this or that. They recognize they don't have any better knowledge of science than they do. They're a sounding board about what they do. That's who they trust. And that's our problem, is that we might be disconnected from that. And then this is a hard one, really. Attitudes that aren't formed by logic or facts aren't influenced by logical or factual arguments. So if you go to that first one, and that's the case, the people have made the decisions based on this gut instinct. They're not making it on the basis of factual information. So telling them the factual information is completely irrelevant to them. It doesn't change their view at all. And I think that's problematic for scientists, because that's our bread and butter. That's what we're brought up on. That's what we're trained in, to produce factual, logical arguments. So the overall view of the study, I'll tell you what it is, because it's gone off there, is that issues about contentious science are usually nothing about the science. And scientific information, therefore, does little to influence it. And that's a problem, because I think, in terms of science communication, spend most of our time trying to think about how to get the information clearer, how to get the language less jargonized, how to get the diagrams simpler, how can we get our information across better? And I think that works for the green group, for the planners and the engineers and those people who live in our world. But I think for these other people, it doesn't work at all. And that means we need a completely different way to communicate that, and that's quite scary. So I thought I'd illustrate this a little bit with something that kind of popped up at the thing today. There was a discussion about geothermal. So we're looking at the public attitudes to do with the deep geothermal in Cornwall project, which is, the drilling is probably going to start now in March. So it's for those of you who remember the Hot Dry Rocks project, it's kind of son of Hot Dry Rocks project. So what we were interested in, actually I'll tell you where it started from. I was talking to the geoscience guys down there, and they were talking about how they'd gone to a kind of public meeting about geothermal, and someone had said, I don't like this notion of you drilling into the granite. And they said, oh, yeah, okay, why is that? And they said, because the magma might come out. And so we had a laugh, and we were like, and I was driving back, and I was thinking, well, that means they know magma, that means they know granite started as a magma. It's kind of a tick. Some of my first years, maybe I'd be happy with that. And then they know we're going for hot stuff down there. So the only really thing that's really laughable is they don't know the geothermal gradient and don't know the melting temperature of granite. Well, actually, some of my third years might know. But you know what I'm getting at. That's actually quite a sophisticated thing. So for us, it is completely perverse. But actually, why not think that the magma might come out? What would stop that? So anyway, I got a PhD student, some of you know her, Hazel Gibson. She started working on this. And Hazel came back to me a few weeks in, and she said, look, I don't even know what I'm going to do, because I don't have the language to talk to people about the subsurface. I'm starting to talk to them about it, and I don't even know where to go. So her genius was to create the cube. So this is cube of, in this case, Carharrock near Redruth. Some of you know it's where the geothermal area is. And it's about 5 kilometres by 5 kilometres area on top, and then it's this cube down here. And what Hazel got people to do was to draw the subsurface. The language was too tricky. What did people think? What could they envisage being down there? And that has been a true revelation. So I'm just going to show you some of these. So the first one is this one. And I need to explain that this is the expert view. So what Hazel did, it's called mental models, it was social psychology, is that she compares how experts do it with how normal people do it. So this is an expert, and actually you look at it and you go, well, that's rubbish, isn't it? But actually, if you think about it, it's got all of the elements that we talk to students about. So for example, there's a fault on here, there's some scale, it says 1 kilometre, 5 kilometres. There is a fault zone across here, it's not just a fault. You can see there's killus and granite on there. Interesting, only the experts use 2 sides. Not a single member of the public used the second side, which tells us about the geospatial, 3-dimensional thinking that we just take for granted and other people don't. So that's the experts one. What about the non-experts? Well, here's one. This is and then it's the interview beside it. So someone talking about going down, hitting the hot rocks, getting hot. I love this last bit. Decent miners, a lot of them, they're virtually in the nude because it sounds like. They've seen the pictures of these stripped off to the waist, battering away. But here's the diagram. And it looks pretty good, actually. You know, you can see there's a mine there, and hard rock, granite, Devonian, stope, veins of tin, copper, zinc. So they're doing it. And then Hazel says to them, well, that's the human subsurface. What about the rocks? Then they pick up a red pen and they write dark. So they've got this very sophisticated view of that. So this is, let me just emphasize, this is Carharrock, this is tin mining country in an area where almost all people know someone who's gone underground. They have a deep cultural affinity with the subsurface. Here's another group, another person. So he's again down to the very bottom of the earth, but it's all broken down, that's where the heat is. So the interesting thing here, well, they draw a surface, even though we've provided a surface, so that notion of what the surface is a little bit vague. You can see the layers is pretty good, actually. You know, there's dinosaurs, and it's gone now. I forgot a dinosaur. Devonian, Cambrian. And what's this? No, it's the core. It's the Earth's core. So apparently this person started drawing it like that, and then said, oh, no, that's ridiculous. And Hazel went, phew. She said, it'll be like this. So our heads go 5 kilometers, 5 kilometers. So that's like 3 kilometers. But you can see why people are worried about magma bursting out if you think that. Some of them just really didn't know what to do. So some layers. Some people couldn't draw, so we had photos that they were allowed to put on pictures of granite. So they knew there was granite and used something else, put it on. This one's interesting. These are buildings. And when Hazel said, well, why is there buildings down there? And they said, well, mining's a long time ago. So this notion of time and of digging down in their foundations, maybe doing an extension and finding older buildings underneath, well, that's history then, that's way down. So the point was that we asked people, they knew what they were doing. These are people who signed up to do a survey about geology, and actually the gulf between even a very basic geological understanding of where people are is colossal. It's really huge. And actually you start to think, well, where else would you get this from? You know, we've got this from undergraduate training, postgraduate training, and all these years. But if you didn't have that, where would you get a sense of the subsurface from? So I think that it's really made us realize that the way even our starting point for communication is probably way too advanced for many of the issues that we're going to talk about. So we've got a whole new PhD student starting looking at where all this comes from. But the interesting thing is, I think there's 2 popular visions of the subsurface. This is one of them, which is like a pristine wilderness. Down there is Antarctica, untouched. And here's us nasty geologists with their drills drilling into this wonderful, beautiful place. But funnily enough, I think there's another one, and that's what the subsurface is. A scary, toxic underworld where nothing good is, and we shouldn't be. And as we go into it, things are coming out that we can't control. So if you look at, for example, objections to carbon capture storage in popular misconceptions, one of the most common ones is this about why people are against it, is a vague notion of tampering with the subsurface. We shouldn't be down there. It's not our realm, because they know nothing about it. It's so familiar to us, it's hard to do. But for other people, we shouldn't be there, and that's wrong. It's just plain wrong. So I think that one of the things then is that if we start to think, well, what is it then that people get so upset by? Some of it is this notion of this deeper world that they can't control. But actually, anyone who's involved in the front line knows that that's just a cover. If you drill into that, people worries about some of these things, you actually get to things that are far more familiar. So some work by Peter Sandman, who's an environmental risk consultant that's done a lot of work with risk in the States, argues, and this is Quadrilla, this is the site up in Blackpool. He says, look, in any typical environmental risk controversy, there's two elements. And the two elements are, one, people overestimate the hazard. So what that means is that if you have something you're trying to work with a hazard, you've got an expert and you've got the public will have it above the expert. And by and large, when you refine it, the expert's probably closer to the mark. But the other thing that's in there is that people are angry. They're angry about what's happening. And so the notion really is that we think of risk as this balancing act between the hazard, this kind of physical frequency and magnitude of the process, and the vulnerability, what's actually there at the surface that's at risk. But what Simon says is if you're in these kind of circumstances, a much more useful way to think about it is this. It's the risk is the hazard, which is the technical bit, and the outrage, which is the social construction of risk. So how are people interpreting the risk? Now the irony, what I think is the beauty of this, and the irony of it, is that it's actually often very difficult to do anything about the hazard. We're not in control of that, and we've got all sorts of very clever probabilistic and deterministic models to do something about the hazard, to bring it down, kind of artificially. We're not changing really often the physical process. But we can actually do something about the outrage. The fact that we choose not to is because it's not seen as geoscience. It's somewhere else. It sits in another domain. It's not technical. So this is Sandman's quote, that public often misrepresent the hazard. The experts often misperceive the outrage. But the overarching problem is that the public cares too little about the hazard, and the experts care too little about the outrage. And this really gets illustrated by this point here, which is Balcombe. And here's a chappie getting his ear just gently pulled by a little bobby. Now, if that person is angry because they've overestimated the hazard, then the geoscientist communication was really easy. We just explain the hazard better. We explain the processes and the size of earthquakes we get. And he says, oh, thank you very, very much. I was really worried for a moment there, but I'm perfectly happy now. What Sandman says is that tends to be not very frequent in environmental risk controversies. What tends to happen is that people have overestimated hazard because they're angry. In other words, they're angry, they've gone on to the internet or they've gone in for material and they've found loads more to be angry about, and it's made them absolutely fuming. So now if you deal with that bit and you reduce the hazard, all you do is reduce it back to that root anger that's still there. So you haven't actually done anything. And so that creates a problem. And so what is it that people are angry about? Well, they're obvious. It's the same things we're all angry about. We'd be angry if it was forced upon us. We're angry if it's something industrial rather than something that we perceive to be completely natural. That if it's exotic or memorable, that, and somehow special, that the consequences could be dreaded. Could the stuff be toxic that's coming out? Could it kill people? Is it potentially catastrophic? This is about uncertainties, whether it's intrinsically unknowable that we're dealing with. And so we're playing around with numbers because we really haven't a clue. Who's got control? Is it controlled by the individual? Them? Not often. It's usually controlled by other people. Equity. Is the risk shared equally amongst everyone, across the whole country, across the whole region, across the whole community, across the whole village, or is it in certain places? Has it got a moral relevance? Who's doing it, and are they trustworthy? And an indication of how trustworthy they are is how responsive they are to when you raise your anxieties. So if you, for example, sitting in a town hall in Cornwall, and you've said you think magma is going to burst out, if the person on the other side of the table laughs and says that's absolutely ridiculous, you're probably going to say, well, they're not taking this seriously, and therefore I'm completely against, rather than this notion that there's actually a severe misconception going on there. So I think these are pretty clear. And the point is that some of them we probably can't do much about, but some of them we can. So responsiveness and trustworthiness, that's usually in the gift of those people who are the front people there, who are the geoscientists or something on the ground. You know, how are they reacting? How are they, you know, representing their organization in this instance? But if you can bring any of these levers down, you're bringing down the outrage in a way that's much easier than bringing down the hazard. So I want to finish really with a more general point about communication, because this, I think, changes the way we do communication. I'm trying to make sense of communication, or science communication, here in this graph. So what I've done is I've put the level, so science is down here, so this would be classic, pure academic science. So this, on the horizontal axis, is the level to which the public's involved or allowed to come into the process. So very low here, and move across to high. And then this one is what's the motivation for the research? So is it driven by just the acquisition of knowledge for knowledge's sake, very academic, pure research? Or does it get all the way up to actually being driven to societal problems? So you can see that, so down in this one is where universities are more comfortable. It's writing academic research papers, going to academic research conferences. And then as we kind of drift across to, well, if you go up to the top, you'll see academics writing policy reports. So the public aren't really involved in policy reports, but we are dealing with issues that are very, very topical. Or we can go right along to here with citizen science. So you measure the number of hedgehogs that come into your garden. Well, that's going back to scientists to write a research article. It's not really resolving some big question, might be broadly to do with biodiversity. But I think the point is that the paradigm shift in communication has been an encouragement of getting the scientists from this place to drift towards the top right, to move towards the public engagement in science, outreach, etc. So if it's outreach, it's right up at the top there, schools and all the rest of it. Public engagement, somewhere in the middle. And I would argue that the role, I think, of the science communicator is somewhere in the middle, is this, what Robert Pielke Jr. refers to as the honest broker. Someone who is a kind of neutral arbiter of the science and is offering up to individuals and communities options as to how they might proceed. In other words, they have some understanding of the public domain and how they think, but they also have some understanding of the science and where the science is telling them to go. You'll see, for example, I've put television and popular science writing on opposite sides of that. So popular science writing, I think, tends to be a case of a scientist or an academically minded person who says, well, let's do a book on rare earth metals. The public will want something on rare earths. I'm going to write a book on rare earths. Why is everyone laughing? Has someone written a book? Have you written? All right, let's choose another one. Carbon capture storage. So it's kind of taken from the point of view is I will write this book because I think this is something the public should know. But the interesting thing, television science works in the opposite way around, as I was intimating earlier, which is that this comes from the public. So the commissioners and the producers are saying, the public are interested in obesity. Let's do a program about the science of obesity. Or I did a documentary on sinkholes. And they asked me to do it, and I said, I'm not really going to do it, because there's nothing new scientifically about sinkholes. And they came back, BBC came back and said, they really want us to do it. It's something that the US co-producer are really interested in. And so I did it. And it was just at the time when all the sinkholes happened in the UK a few seasons back. So it came from the other side. So the next few slides is me trying to justify my existence by saying, what is it we can learn from that domain that might help us about how we sell, how we do that middle bit. So I'm going through it quite quick because a general point that I want to go into. So basically, the programs of the last 15 years with BBC Science is about hazards, climate change, generic earth science, or more recently, things to do with energy. And in each of those has been trying to frame the science in ways that the audience is interested in, not what I'm interested in. That's been the key motivator there. So it's one thing that it's an ingredient is capturing the wonder, the awe of the planet. We've all been probably watching Blue Planet. Amazing. So you watch that stuff, it just is beautiful, and you care. You think, this is amazing. We cannot kind of lose this type of thing. So being able to do that is really strong. This is the Crystal Cave in northern Mexico. It's gypsum. It's the most simple mineral, but it's extraordinary. So the ability to capture the wonder of these places is really important. I sometimes think we forget about this bit. That when we get into geology originally, if you come back, it's quite funny sometimes to think back to your teenage you and then explain to the teenage you what you're doing now. They're probably going, oh my God, that's so boring. And the reason it's so boring is because that's not what got you into it. You got into it because you loved getting out into the wilds and landscapes or whatever, seeing 30-meter high crystals. So we shouldn't forget this, and it works really well. It's about people. So this is, people have probably heard me talking about this before, but I brought up people with Ted Neal at the Geological Society, and this is his words, and everyone who Ted's can probably hear his voice in it. He said, it's a fact often overlooked by scientists that most other people are mostly interested in other people, and they're mostly not interested in anything else. The fact that scientists are more interested in average in things and ideas marks them out, marks you out, marks me out, is mentally unusual. My kids love the Kardashians and Made in Chelsea, and they sit and watch it. And the reason they do it is because they're interested in people. People on the bus sit and read OK Magazine and all of that. They're interested in people. So we can do something about this. We have loads of people. These guys are wildcat drillers in Pennsylvania. That guy's in his 90s, still drills a couple every year. I went out there with those guys, and it's funny, we were up in the hills, and I said to them, do you ever frack? And they went, nah, not really. He said, it's a real mess. You've got to get the water trucks up here, and the environmentalists don't like it, so we don't tend to frack. I said, okay. And he said, we tend to just pop them. I said, pop them. And he says, we just drop nitroglycerine down. That didn't make it to the screen. So. But that also means it's about us. Because we're people. I don't know if you noticed, but we're people. And what I mean by that is the scientist is the gateway to the science. And that is something that's quite uncomfortable for some people, and it's certainly uncomfortable in the old way of the scientific methods whereby really the investigator didn't count. Could have been anyone. But we know that was rubbish. But more importantly, it's not very good for communication because your science might be quite difficult to get into, but you're much more likely to be easier to be able to access that. So that us being seen as the thing that showcases our research is a really important way into science. And I think that's something that we need to encourage. And I think whenever I do sessions, the kind of early career scientists just get that completely. And I think it's harder for other people that have been entrenched in the old system. It's about so what. The so what is, well, why is it relevant to me? So this is a classic communication from the science model, of the scientific method. You immerse yourself in tons of detail, you drill into that, you learn a little bit more, you maybe decide to do a dissertation, a research project, you collect some data, you analyze that data, and you come out with something, and you want to communicate it. And yet for the public, they flip that completely around, and you start on that really sharp point there, where they say, what's this got to do with me? Why are you stopping me to tell me this? And if you can't get past there, that's it. It ends just there. But if you can, and it could be you as the gateway, you can draw people more and more into the detail of what you're doing. But if you try to do this model, it fails abysmally. So I think one of the things we need to be thinking about in terms of training is not to badmouth this, because that works for scientists and engineers and a whole bunch of people, but to say, well, there's another way of doing it. And actually, for my students, the way of doing it tends to be what they came in with, It was the way they were when we came in before they did that first essay, and we wrote red pen all over it and said, you should use the third person, you shouldn't use I, you shouldn't write in such a lyrical, interesting language, you should be very boring, you know. we kind of have worked them out. So I do the fourth year of our MJOLs, Science Communication, I try and get them to reach back into how they used to be. And the last one really is this notion that it's not about facts, it's about stories. So the problem with facts and information that I highlighted earlier is that it's not very effective for these other audiences. But actually facts are very temporary, transient things. You pick them up, you use them, and then you get rid of them. So they don't hang around too long. But stories, compelling narratives, hang around for a long time, myths, etc. So the BBC Science, when I started working for them, sent all their science producers on a Hollywood script writing course that said, how do you make Hollywood movies? And they came back and they did BBC Science in the same way. So this notion that there's certain ways of telling stories, narratives, is something that all journalists know. And I think if we can capture that, and you can put the facts in, but it's a story that we need to think about. But, so those are all fine. Those are all things that I think work on television. But the question is, do they work when it comes to really critical issues? And I could choose a number, but this is the one that's fixating me at the moment. We're working in Istanbul on the seismic threat to Istanbul. Hagia Sophia here, you know, it's been, ever since it's built in 600 AD, it's been knocked down by earthquakes such that basically all these stone buttresses that's holding the thing up. So that building has been struck by devastating earthquakes for millennia, but that city behind it is comparatively untouched by earthquakes. But we know an earthquake is coming. This was the earthquake that affected Izmit in August the 17th, 1999, killed 18,000 people just to the west. And what we know is that earthquake that's shown in those yellow stars in August, the big one, in November, the smaller one, is a result of a remarkable sequence of earthquakes that started in the east in 1939, and it was 1942, 43, 44 jumps back for a very small earthquake in 51, and then 57, 67, and 99, such that now, and you can see that further to the west, the North Anatolian Fault, that's the causative structure here, had a big earthquake in 1912. So the only significant segment of that plate boundary North Anatolian Fault that hasn't ruptured in the last 100 years is this segment here, the Prince's Island segment that sits 20 kilometers south of a city of 13.5 million people. So the notion that you won't see Istanbul struck by a major earthquake in your lifetime is very unlikely. You will see it hit. It's offshore, it's on the Marmara Sea seabed, but you can see the bathymetry, so it's probably going to be tsunamigenic. And this area of the coastline is incredibly developed in terms of industrial plants, power plants, harbours, ports, chemical factories, etc. But it's the city itself that's the real problem. So there it is, packed to the gunnels, a mixture of modern buildings that was probably going to be fine. But the vast majority of those buildings really have developed over the course of the last 60 years or so as people have moved from Eastern Anatolia across to Istanbul to develop the industrialization of modern Turkey. So these people are crammed into buildings that were just built very, very fast and shoddily without any approaches of engineers or architects or planners put up. And so the psyche of the people that are living in Istanbul is really quite extraordinary. What's known about Istanbul is, despite having this really accentuated seismic risk, probably the highest on the planet, the uptake of seismic preparedness, by whichever measure you have, whether people have emergency kits or plans, whether they've looked at their structure, put the shelves on properly, whether they know well where the mobile hospitals might be after. Whatever measure you use, they come pretty much at the bottom of the list of earthquake-prone countries. So you have this huge sense of the risk, but actually very little getting done about it, which is the risk paradox, really. So the question really is, how do we kind of get into their heads about what is going on? Well, one of the ways that we did this is, so I was in an EU project called ALERT, which is on tectonic plateau uplift. And that's a bunch of PhDs to do with geoscience, geophysicists and geologists, and my PhD student, who's Johanna, who's a visual anthropologist. So the interesting thing, what we're trying to do there is, to what extent can film be a way of cutting through this? In other words, so when I thought that people didn't know, so what I wanted Johanna to do was to go into these districts and explain to people there's going to be an earthquake. She phoned me up at the first field season when she went in for a recce. She said, everyone knows. Everyone's saying there's going to be a big earthquake, isn't it? It's going to be really big, isn't it? So the communication had worked. Everyone knew. We had done our job as scientists, we'd done it. So the question then, they said, well, what do we do about it? Because no one tells us anything. No scientists have ever come into our districts and told us things. We can't get any information. If we go into the internet, we get technical reports. What is it that we actually do? So we kind of played a trick, really, on the students on this thing, where we had a science communication workshop that we designed. And as they arrived, we took them straight through the room and into minibuses, and we took them out the back. We took them into the at-risk neighborhood. This is Zeytinburnu, which is one of the areas that's been high seismic shaking, so this is underlain by weak sands that will amplify really quite strongly. And we met social scientists that took us around explaining what the city was doing about this, and we met local residents. And the key thing that we wanted here was we wanted the geologist or the geophysicist to see earthquakes the way that normal people see earthquakes. There is nothing good in an earthquake if you're a normal person. If you're a geologist, there's tons of good things. It's the way we see the world, it's the way we see into the world. To be honest, it's where our funding comes from. There's a whole bunch of things that we are intrinsically uncomfortable with, but we accept. But if you're said that here, there is nothing good in an earthquake. And how does SEDAT find out that information? So we went, this is a different district, Okmedani, where we talked to the head of the neighborhood association, and we bring the maps. He's never seen these maps before. We bring these maps, and he says, do you know, I don't think my area's at risk, because in the earthquake in '99, not a single building was affected, and yet they're knocking it down. I think it's political. I think it's because it's very high real estate values in Okmedani. And he says, I think that they're just using the earthquake as an excuse to basically put up a shopping mall and luxury flats. That's what they're really doing. He says, but I've never seen a scientist. I don't know anyone. And so this was that you can see the awkwardness, really, of the geophysicists. And then we go back, and this is what I was really impressed with really today in that decarbonisation, that panel, because it's the same thing. And these guys are discussing what their role and responsibility is, what their ethical role is as a geoscientist. What should they do? Is their role to do the science as an independent scientist and put it out as research, and then you leave it for other people to do it? Or should you then move into the mode of actually trying to do something about it? To move into the role of advocate, as we talked about earlier, or even potentially down the line as an activist, someone that's actually going to embed themselves with that local community to make them safer. Now that is a slippery slope that many scientists fear, if they drift into being an advocate and then suddenly an activist, and then you've lost that independence of being a scientist. But I think the key thing here is that that is a discussion that I think in general in geoscience we don't have. We just assume that the technical stuff we do is enough and that that will carry us through. And I think that I'm talking about earthquakes, but we could talk about geoenergy, fracking, we could be talking about climate change, we could talk about minerals. These are contested political issues out there. If it matters, it's a contested political issue. So what is the role of the geoscientist in that? I'm going to embarrass Joel, who's here, because me and Joel wrote some stuff up recently about what I think we called social geology. But this notion that geology, geoscience needs to have a kind of social dimension. Naomi Oreskes is a great historian of science. Has written a paper that said, the title of it is Earth Sciences is a Social Science. In other words, that if you're dealing with stuff that's in the interface with society, society is actually affecting the physical processes that's actually happening, the actual physical process. I'll explain more. But we need a new way of thinking, and this talks about the role of geoethics, about communication, about multidisciplinary drawn from the social sciences. But I want to finish really with going back to this slide, because I said that this is the landscape of science communication, and we're in the middle of this honest broker. But I want to contrast two different other modes in here. If anyone who does any science communication, it is fantastic. It's a brilliant thing to do. And I know you do it because I once did a survey of the BGS, and there was loads of stuff coming out where people are really excited about things to do with geoscience communication. And there's lots of different things you can get involved in. And this is a long quote, but I really like it because it talks about, and you can just skirt through it, it talks about who we involve in this new frontier of interdisciplinary. We involve in people from the natural storyteller, novelists, poets, creative writers, film and television producers, visual artists, all these people working with online social media, they're all part of this science communication, along with environmental and social scientists, but inspired by moral and religious philosophers getting their point in there. It's this great melting pot. And we're trying to accurately communicate with science in imaginative, compelling, and novel ways. And that then provides us context for value-based discussions about what it is that's important in many of these things. This one was talking about climate change and basically providing the resources and the opportunities for direct participation of the public. So it's a broad, sprawling landscape that's extremely exciting. So here's the site. So there is a problem, I think, with this. And that is that if we look at how we deal with it down here, because science training, science communication courses really emerge out of universities and out of research institutes. What are they doing? Well, I would argue they're doing this. They're making and selling. They're doing what business used to do. They're producing research papers and they're pumping them out the door. They're wrapping them up in something. They're doing a press release and they're selling it. In other words, the attention is internally to what they're doing. They don't really care. As long as people buy something, they don't really care what it is. Out it goes. If you look at what the other end of that, what happens in a business and a business marketing world is that businesses evolve around about the 1950s into a more sophisticated place where marketing arrives and basically they sense and respond. They listen to their customers or clients. They say, well, what do you want? All right, we can fix that. We can make that. Back it goes. So the audience is king, the client is king. Now, that is where we're getting shifted to in terms of public participation. We're saying you should listen to communities. What do communities want? I think the issue with this is that both of those are short-term. The make and sell is our cycle of research calls. We've done a research project, it's produced these interesting results, and now we're going to follow it on. And actually, there's some money over here, and we'll do that. So it's 1, 2, 3 years. I mean, we blame politicians for this. I think we're just as bad. And I'm really thinking the universities here. But the sense and respond one is short-term as well, because that's listening to what the public are interested in now. And that's assuming that they know the longer term. But actually, we're the ones that are more likely to know the longer term. But we're too busy doing this making and selling. So there's a problem here that actually both the sense and respond and the make and sell, which are based on journalistic devices of the news media and communication media now, I don't think are fit for purpose if we're actually trying to look at things like climate change and long-term disaster risk reduction and some of these other issues, resource demand. As geologists, we're very familiar with this axis, which is time. So if we're really interested in longer term, decades, then we need to look at those businesses that are actually thinking long term. And there are some that look at sustainable practices over the long term. A business like Patagonia, for example, or there's many of them, Unilevers, that are starting to really think decades into the future. And they've got a model called guide and co-create. The guide bit relates to us as academics, that we have a sense of what the trajectory, the direction of travel is. But we're not sure, because it's going to all change, because humans and social systems change, So the co-creation is constantly working with the public as we go to say, is this the direction we think this is the direction? Is this the direction we think this is the direction? But we've got a sense of where it's going, and it's driven by us, by science. That requires a sense of purpose. So all these big companies are purpose-driven strategies. So they have a sense of the long-term goal that that organization wants. And in terms of purpose, the definition is a pursuit of an ambitious, clear, enduring, and overarching goal which is motivating. And that's the key, is motivating people to get excited and buy into something that's going to be decades to actually resolve, rather than something that's just 2 or 3 years down the line. And I don't think science has got that, to be honest. And I don't think the universities have got that. And I think that's a real problem for us. So if you think of the areas that have got purpose, it's religion that sells a very, very simple narrative. Trust in us, buy into this, turn up every Sunday, and this is what you'll get. Or it's other very, very simple messages that sell the future in a clear and precise way. And I think this is uncomfortable probably for science, but it seems to me that we have got things like the Sendai framework that is telling us about what's needed, COP21 and what the climate change emissions are and where we need to be by 2050 or 2080 or whatever it is, the Sustainable Development Goals. These are very clear indications of where we need to get, and science needs to help get there. So actually, I don't think it's such a problem that science then develops a sense of purpose that says, that is where we're going. We think this is the way. We don't actually know how we're going to get there, but we're going to constantly be talking to people to see what those changes are. Because we know society is going to change as we go, and what we start out with is not the route way that we're going to end up with. But we have that sense of what the end game is going to be. So I'll just finish with a slide, because I think this is so that's my point really, is that if we're underpinning all of these, which are very well-meaning, they're full of metrics and measurable, but they're not exciting. They're not compelling. They don't get people fired up and really want to go for it. And actually, geoscience doesn't sit there virtually anywhere. I mean, they're in there underneath. So I think geoscience needs to create these meta-narratives about where we're going to be for this better future. And the final one then is really this, that science isn't enough, and then we need better stories. Thank you.